Alright, so let's see what we got here. So if you just, do the free only, we'll see what we got this time around. Like each boot camp, there's always like other cool things that come out, so why not make something cool around it? So one of the things to look for, because what we're going to be doing is we're going to create something mobile. So we're going to look for something that's not like too crazy looking. Let me see, this town creator kit might seem cool. So this kind of stuff is actually perfect. Yeah, so let's do, this one's not bad, keeping it on the list. Stylized, simple cartoon city is also not bad. I've done a class with this once. What else do we have?
Japanese
I know which one you're talking about.
Very well made.
This one's kind of sci-fi-ish.
That's really cool.
Yeah.
That is really, really cool. It's light. It's a light version of something. I think.
Now I'm trying to see, like, how do you... What's the full version look like? Ah.
That's so.
Yeah, so that's the full $50 version.
That's a full game.
Yeah, so let's say let's do this one, right? So it's called Sky City Light. So just download that. Okay, so it's just gonna be kind of fun. We're just gonna kind of arrange our scene and just basically prepare for what we're gonna be doing next weekend, which is kind of coding this little game basically. Once you get it, just import everything. Let's see if it works first of all. But then if you really like this pack, for example, maybe you'll go ahead and just buy the $50 thing if you want to make something out of it later on down the line. But I think we got enough in this free one. It's going to say API update required. You just click I made a backup, go ahead. What that means is basically Unity always kind of releases new updates to their software. Now they have really great backwards compatibility. So if something was developed with Unity 3 and we're at Unity 5 now, Unity includes tools that convert everything for all the newest versions, including code. So if a certain function has been renamed, or if certain ways of doing things have changed slightly, it can pick up all the old code that you wrote and just update everywhere where things have changed.
Cool.
So that's one of my favorite parts about Unity, is that even if you wrote something 2 years ago, chances are you put it in and it'll still work automatically. Maybe some things might need to get manually changed, but for the most part, it's able to kind of update everything pretty well. Funny thing was, someone actually asked me on the YouTube video for one of the classes to upload the Google VR zip file, because they were like, it was giving me an aneurysm trying to figure this thing out, and I feel for that person, because I literally was about to teach you guys Google VR. I was like, go to Google VR, download the package and import it, and I was like, wait a second, I don't know how to use this anymore. So I'll probably have to go back and figure it out again.
Okay.
But like, it's just it's silly, you know, like for them to change it that much.
Yeah.
That it's just You know, maybe I'm sure they have good intentions and they're like, we're trying to make it simpler, but
Yeah, but it ends up confusing people.
a lot. It really does. And I get requests like that sometimes, like, can you upload the zip file? You know.
Yeah. So you guys didn't export anything last Friday?
No.
Okay.
Yeah, so whenever you got your Sky City Light, you should see a Sky City Light folder.
Yep.
And in there, there's a scene folder, and I'm assuming that's where the whole scene is basically set up. If we double click that, we'll have this. Now, how modular is this stuff? Oh, it's great, actually. Yeah, so
You just put that in?
it's just Sky City Light. There's a scene. So Sky City Light folder, and then in there there's a scene folder. And if you just double click that.
Yeah.
So now what we're gonna do is I want to save this scene as our own scene, so that we can keep this old version of the scene in case we ever need to go back to their scene. So you just do save scene as when you have their scene open, and just name your scene, you know, I don't know, like game or something. So now if we make any changes to it and whatever, if we ever need to go back to the original, we can. So, and I noticed this when I was checking, there's some advanced concepts here that I'm sure you'll kind of appreciate. So there's level of detail. Now, level of detail, maybe you'll know what it is, maybe you don't. But basically, level of detail is really great for large environments. We have lots of things. So sometimes you'll put like a high detail version of an object, and now maybe you don't see the difference, which is actually good because you're not actually supposed to notice the difference. But notice here how when I pull on the bottom right, you see how the triangles right here, it says 1,700 triangles, and when I go to LOD1, it's 778 triangles. So we're even reducing it by more than half the amount of detail when you're looking at this platform from far away. Because since you're so far away, you actually don't need to see that many details. You won't see them. They're really far away. But if you're still using the same 3D model, the same textures and stuff, it will still impact your performance the same. So if you're really far looking at like a city, such as this, for example, and you have lots of these things all across the scene, it would hit on your performance. Yeah. But using LOD, it actually lets you manage like the distance that high details and low details pop in and out, basically. So we'll go over how you make an LOD object and just kind of best practices with that.
Does it do it automatically? Like if you have the LOD attached to it, it just automatically optimizes it for you.
Yeah, and sometimes you can tell, I can kind of tell how it just became a little more jaggy. It's right here.
Oh shit.
I don't know if you can tell,
Yeah.
Slightly here, you can kind of just look at the roundness of the edges.
Mm-hmm.
You can see that, right? It's very slight, and it's, you know, but it helps a lot. So these, especially, you know, with VR stuff, if you're gonna make some really big complex scenes, level of detail is pretty crucial.
I think one of my characters had LOD, and I had no idea about that one.
Yeah, so it came with like two versions, like
Yeah.
a higher detail and a lower detail or something like that.
I don't know. When I put it in, it just said LOD above his head.
Maybe. But yeah, so the first thing that I actually want to do here is I want to talk about the skybox, right? The skybox and some lighting things. Now, I just want to see if they actually have some calculated lighting here. So one way you can do that is just go to Window. So I need everyone to follow me here. So go to Window, Lighting, Settings. And it'll either open a separate window or it'll open it like in here or something like that. Just pull that off. Just pull the lighting window out as a separate window.
Mm-hmm.
So in here are a bunch of settings like the skybox and the amount of ambient environment light. So if I tweak which is environment lighting intensity multiplier, you see that how it's affecting like the amount of ambient light. But yeah, what I actually want to do is I want to uncheck right here where it says auto generate, you see in the bottom, automatically generate lighting data. It says auto generate, just uncheck that. What that basically does is every time you tweak something in the scene, it'll try to calculate the lighting again. So we don't want to do that because that can slow down things a lot. We kind of want to calculate the lighting once we're ready. But what I want to do right now is actually I want to clear if there's any lighting already calculated. But the way you do that is you see the generate lighting button on the right. There's a little arrow there, and there should be say clear baked data. So just let's click that, and I don't see any change, so that's good. So there's been no lighting calculated yet. And this is actually going to be really fun because the Unity lighting engine has gotten pretty fun to work with and robust. And I'll try to show the differences between a well-lit scene and a not well-lit scene, and how like it affects the quality of your product basically.
What do you mean by calculate lighting?
So I'll explain. So basically, and maybe this could use some whiteboard, I'd say. So. Oh. Yeah. Okay. I don't know why it always works. Yeah, sorry. You know what? I can actually show better examples on Google. Yeah, so the reason why in games you have to calculate lighting is because what happens is in 3D when you're doing like realistic lighting, so most 3D engines use things like ray casting, and like there's a few like advanced techniques that you can use to simulate basically how light bounces in a scene. So what happens is, if say, and I should pull up Blender and just kind of show you an example of how this looks, right? So this is like a 3D modeling package, for example. So let's say I want to do just like a very basic scene, and you should be paying attention because you asked me the question. So I'm just gonna make a floor, and I'm gonna make a sphere. Put the sphere right here in the middle, and voila. Okay, so this is practically unlit right now. We're using just a very, very basic lighting. Even here, you can kind of see the specularity on this. So all that stuff is considered lighting. Now, if I just switch my rendering engine, but before I do that, actually, I'm going to just make a camera. So it's very similar to how Unity works. There's always a camera where things are kind of looked at from. Oops. And I'm going to open another window over here. And here I'm going to just do the camera view. Okay, so that's my camera view. So now let's say I just render this as a new window. So if I render this scene, okay, that's just black because we have no light. So I'm going to add a lamp, a hemi light, which basically is just kind of like, you could call it almost like a sunlight. So that's a rendered scene. Now it took, it was very quick, almost instantaneous, but it still took calculation to kind of do. Now there is not many details here, for example. Now if I start kind of bumping up some details, so if I go to my light, and instead of making it, say, a hemi, if I make it like a spotlight, let's try to render that. Should get something like that, and it has like a very kind of dark shadow here and a spotlight effect. Now if I start tweaking this and kind of like the amount of sample buffers, and let's say if I just do actually a ray shadow. So what happens is basically whenever in a 3D engine you're doing any kind of 3D graphics, lighting is calculated and so are shadows. So the way that happens is oftentimes it's used with ray casting. So basically it'll take like the direction of the light and it'll shoot a ray, and it will see if there's something in between that ray, and if there is, for example, it'll cast a shadow at the bottom of it. That's kind of like a simplistic way of explaining it. But there's more advanced things that happen with ray casting. For example, sometimes a surface has reflectivity. So it tries to simulate what this, light in physics does in real life. Is a light sometimes can bounce off a surface. If it's fully reflective, it fully bounces off. If that ray reaches back to the viewer, so imagine if we're just viewing directly like this, and the light in this sphere is supposed to be fully reflective. If the light hits it, it'll come back to us, and we will see basically a reflection of the scene. If it's semi-reflective, if it's like 50% reflective, you will see 50% of the material and 50% of the scene. So that's part of what a lighting calculation does. But say like I rendered this, for example. So now you probably noticed that the sphere, it's a lot more kind of like precise of a shadow. But let's just go on from there and add a few more things like ambient occlusion, for example. Let me just see if that does the effect that we want. So ambient occlusion, what it does, it's another layer of lighting calculation where not, obviously without it, you see that, it's just kind of like black where there's a shadow. Now, it doesn't look very, realistic because main reason is nothing's ever like absolutely black like that unless you're in a room that's like that, and that's an effect that you desire.
Why isn't the light like white? Why is it like gray like that?
So the light is because probably the intensity of it. If I increase the intensity of the light, it'll probably start getting brighter.
Okay.
But it has to do with the distance of the light and the fall off. So there's a bunch of these settings, and they're mostly like a 3D program related. But I just wanted to explain real quick, like something like ambient occlusion, for example, or say even now let's do environment lighting. So what environment lighting does, and you can see it almost had the same effect as ambient occlusion. It basically simulates something like the sky and the sun and the clouds and whatever. It's never just fully black. There is some shadow, but at the same time, it also kind of has a little bit of fill light there. So you can see this effect is it looks a lot better than what we had before.
Yeah.
Still a little grainy. Now, if I want to not make it so grainy, what I can do is I can bump up the amount of samples that we're using to calculate. So what that basically means, instead of shooting 4 rays per X amount of unit space, now we're shooting 16, and you can see the calculation is slower. You see that?
Yeah.
For only 1 frame. Now notice, not so grainy anymore, right? If I just bump those samples way back down to like 2, and I render that again, you can see the graininess, right? And that's just simply because it just doesn't have enough data. It hasn't shot enough rays of light to calculate that shadow and how accurate it is. So in Unity, calculating lighting basically is kind of the same thing. You're calculating things that are just too slow to do in real time. Something like the bounce of the sun and stuff like that. It's just currently computers just aren't capable of doing that kind of stuff in real time, especially mobile devices. In the future, it might, and you might not need to calculate lighting. You could just put a light there and it'll just react in like a physically accurate way. But the way that things are currently is you as the developer will usually have to pre-calculate light. Light your scenes the way you want them, kind of get the exact look, and then when you calculate the lighting, it saves that once, and sometimes it can take hours to do on your computer, but it saves that as a file format that Unity can read, and then for your clients, for your end user, they don't have to do that calculation. It's already calculated and it just runs very quickly. But yeah, I hope I was able to just kind of explain like the difference between why it's actually calculated, because it's slow. You might not see it if it's like a very simple scene, but for many lights, we're talking like 20 lights and a sun and a sky and reflective objects and stuff like that, you're gonna have to calculate the lighting basically to get a good effect.
And that's what baked means?
So baked is basically that calculated lighting gets baked into a texture. So baked is like it's a figure of speech,
Yeah.
but basically it's like it's a way for it to just kind of finalize it as a texture. At the end of the day, everything kind of gets slapped on in 3D as some sort of texture onto an object. So when you bake lighting, you're basically, after all those rays have been shot and stuff, you're not actually saving those rays and putting them on a phone. You're actually just putting those textures that are the result of the rays at the end of it. And that's what it means to bake lighting, basically.
It's almost like billboarding, but for lighting.
Kind of, yeah. But yeah, it's textures are very low performance. It's the actual calculation and stuff that's very slow. So yeah, we cleared it. We didn't really see any difference in our scene currently. So that's all right, because we're gonna want to actually calculate our own. Now, yeah. So some of the stuff. So I've noticed they're using LOD. Another thing that they're using is they're using what's called PBR materials. That's a fancy word for basically we have a material with a normal map, a specular map, kind of like the stuff that I kind of taught you in the first day. So you'll notice that it's got these nice bumpiness and stuff. Say we didn't have any normal map, it would just look like that. But with a normal map, we got this nice kind of effect that it makes it look nice. So that's part of the reason why the scene looks so nice, is because it has very very thought out, very very kind of nicely PBR materials, which means basically physically based renderer. That's what PBR stands for. So let's see here. Now, yeah. So I want to just skip out on the PBR and the LOD stuff. Let's just talk about the sky for a moment, right? So the skybox, it just kind of comes as part of Unity. You could create your own skybox by using an inverse sphere in a 3D modeling package, but most people won't do that. And you don't need to. Honestly, the skybox is pretty good the way that it comes in Unity. But I'm going to explain how you can use some skybox off the asset store, and then what we're going to do after that is I'm going to actually show you how you can make your own skybox out of a picture, for example. So if you just go to the asset store, for example, and you just search up skybox, you'll see some skybox packs will probably come up if I just do free only. So I kind of want to do this purple space nebula one because this is kind of like a sci-fi scene. So let's do kind of like a little sci-fi space background for it. So just download the purple space nebula skybox.
You can create a skybox from a flat picture?
Yeah. To some extent, you should probably use panoramic pictures more, or 360 pictures would work better. But you could take it into Photoshop and kind of work with any picture almost to make a skybox. So with this skybox, I'm already seeing how it's importing it. It's using something called the cube map. So I'll explain what that means in a second. But once you import that, you should see a folder called Skyboxes, and in there it should say Purple Nebula Skybox. And if you click on the Purple Nebula Skybox, you should see here it has a front, back, left, right, up, and down. So that's what it means to basically for it to be a cube map. The texture itself was split up into 6 cube faces, and the final result is a fully enveloped sky. Now you don't actually notice that it's like a cube, because when you're at the center of a cube and the way that the projection works, you actually never really see the meat there unless the texture isn't designed properly. But creating this type of skybox requires some special tools to do so. As you see, there's 6 textures. There's Pano, and there's a few other programs that can convert like a panoramic image into those 6 cube things. We're not going to create a skybox using the 6 cube method. We're going to do it with one panoramic image. But yeah, this is how these guys did it. Now, if you want to apply this purple nebula skybox, it's very simple. So all you do is you go to Window, Lighting, Settings, and up there you should see default skybox as a skybox material. You just want to pull this purple nebula skybox into there, and voila. Looks great. Now, this is, it's very obvious, you can get already created assets and download skyboxes. There's very high quality ones. I definitely recommend you do that. But say you wanted, to understand how a skybox works and how you would actually make one. So let's go to, good old Google, and let's search up something like panorama sky, something like that. Sky panorama or panorama sky. If we get like, say, and we probably want the size to be a little bit bigger. So in Google, if you just click Tools, Size, it'll give you like the little size option. So I want to go over, 2 megapixels at least. And say we go for like this one. You might pick a different one. Just kind of make sure that it's horizontal like this. So I just pull it in here, and I'm gonna just pull it into Unity, and we'll just start playing with it right now. Now, I'm assuming, and then there's probably will be things to tweak, but say you picked an image and you just want to see what it looks like on the skybox. So when you have it pulled into Unity, I want you to click the texture that you just pulled in, and up here in the inspector, it has the import settings for the image. So you see where it says texture shape 2D. I want you to select cube, and mapping, latitude, longitude, layout, so cylindrical, and then click apply. It'll take a second to cut it up and to do the right things with it. So it's just, when you click the texture, it should just say texture shape, it should say 2D, switch it to cube, and then where it says mapping, it should be latitude, longitude, layout. And then you'll get this kind of spherical, kind of almost ready to be a skybox. So when everyone's got that, then what I want you to do is I want you to right click in your project and create a new material. And that's going to be a new skybox material, and just call it something like new skybox. And when you create that material, you're going to switch the shader from the standard shader, which is up here, and you're going to find skybox in there. And I believe cube map is the one we want. Skybox cube map. And then you should be able to just pull in that texture we just created into the material slot there. So you just create a new material, you switch the shader from standard to skybox cube map, and then you pull that texture into that we just created earlier, and you pull it into that slot right there. So now if we go to Window, Lighting, Settings, and we pull this new skybox that we just created, you should get that. So it's not the worst thing for something just pulled off of Google. There's a seam, and this is to be expected because we didn't do anything to this yet. But the rest of it doesn't look so bad.
How do we? It's not liking my.
So let me see what you have. So you have to make sure that's Skybox. Yes, if you.
Are you up here?
Yeah. Um, oh, that's a material. That's the texture. You have to create a material.
Oh, okay. I didn't do that part. Got it. All right. So I need to.
I feel like you had it. I saw you had it selected.
Yeah. So that.
Yeah. That you want to pull up there.
All right. Got it.
Yep.
Cool.
So most people should get that seam, and that's completely normal. And I want to see if there is actually a way. Yeah. So if you click the texture, so that spherical one that we created, you should see where right under mapping convolution type, you should see fix up edge seams. You see that little check mark right there?
Where is it?
Fix up edge seams. Just when you click the texture itself, the one that you made into a cube.
Mm-hmm.
Now I don't know how good that's going to be, but let's just try it. So try to re-render everything. Back in the day, you used to have to just do it in Photoshop. Yeah, I figured it still wouldn't look too great. Because it's just impossible for it to do it automatically. But
we need both sides to be kind of similar.
yeah, so the quick way of doing this in a tool like Photoshop, for example, is I would just open where my file is. I'm gonna take this and just pull her in there. Now, what you do is there's just a quick tool. If you go to Edit and Filter, Other, Offset. So you want to offset the horizontal by a certain amount. Just make sure you remember. So if I offset by negative 1024, I can see the seam right here, and now I can work with it. So the quickest way for me to fix up a seam is to just take one part of the seam like this, copy it, paste it, transform it, and just take it like that as a second layer. And then I'm going to take the eraser tool, make it big and very not hard, so like soft like that, very big, and just kind of like do that. That's like literally like easy peasy way of doing it. And then to fix and then to fix this, because it's very mirrored, you merge those layers, and then you take something like the clone stamp tool and you pick some other clouds from here, and you just kind of like, you know, just do your thing. And there it is. And then maybe these, you know, these things like this building, maybe I want to just put a field here or something. So I don't know. I'm not gonna spend too much time on this, but that's kind of like the gist of it. If you want to not really see that there is a seam there. It's not the best image for this, but yeah, if I just say I'm happy with that, I just Control S to save. And then because you worked on the same file that's in Unity, when it's done saving, it's a really big image. I should be able to just go back into Unity, it'll re-import everything, and we'll see the result.
So Unity's always looking at the original file?
Yep.
Oh, okay.
It's not the original file that you pulled in from your desktop. When you pull it in from your desktop, it gets put into where your documents are, where your project is.
Mm-hmm.
And then there, you work for the files from there.
Okay.
When you pull it into Unity, it basically makes a copy of the file.
Okay.
So now if I go back to Unity, it'll just do its thing. And just watch for this seam right here, and watch it get fixed. There it is. So that's a skybox. The only problem with this is the tippy top.
Yeah.
And honestly, I've seen even like released things not mind the tippy top. The bottom looks kind of cool, trippy. But my way of fixing the tippy top is like just again, this is a very bootleg way of doing it. I'll take like a spherical selection of something like this. I'll copy that. I'll make a new image. Paste it in there. Actually, before I copy that, I'm going to deselect this. I'm going to feather. So feather, what it does is it just kind of it kind of softens the selection. So I'm going to do a feathered selection, like so. Go back in here, paste it. No, I'm going to make a new image. It's not big enough. Paste it, and then delete the background, just to keep the transparency. I'm not sure why it's yeah, I think I grabbed too close to the edge. So it doesn't have to be that feathered, maybe 64. Grab it like so. New image. So just make sure it's something like this. Delete the background, then save as a new image. Make sure it's a PNG so it has the transparency. Call this the top sky cap. Or a sky patch. I always call it like something like that, like a sky patch or some shit like that. So you got it in there, you pull your new texture, and then all you do is you create a plane. You pull your new texture onto the plane. You make sure that it's a type of transparent or fade, like that. So that's what we get now. Then you could probably guess what I do next. I rotate it so it's facing down, right? Oops. And then I will just take this up to the sky. Instead of using the lit, because it's actually reacting to the lighting, I'm just gonna use an unlit transparent shader, and then I'll take it up to the sky somewhere comfortable, and then I will scale it up like so. Now if you put it really far away, you won't see it so much when you're moving around. Seems that there's some fog in this scene. Isn't there? Yeah, there's a fog setting here.
Oh, cool.
I'm just going to disable the fog. And there you go. So it's not perfect, but it's one way to get rid of the cap if you just put it even higher. Just higher and bigger. This was just a very quick way of doing it, but it's one way to fix that. See that?
Mm-hmm.
So now the top is also goody. If I disable that, that's what it used to look like, remember? This is what it looks like now. So for the most part, you could look anywhere and it looks like a sky, right? So that's one way you can make one. Just easy peasy, like less than an hour of work, And you can create like your own custom skybox from a photo that you take, or from something off the internet, or something that you make in Photoshop. I actually don't mind this. This actually looks better than the nebula. It's very stylistic. It's very kind of purple, right?
It's very anime.
Right? It's kind of dreamy and stuff. So we can keep it this way. I'm actually gonna yeah, I'm gonna just put a quick break on this video.